Good morning, everyone. Hope you're all well. This is Mr. Zatola here to do a little discussion about fronts. This first video is going to be on cold fronts. If you are completing the assignments, the Google Classroom, Mr. Goodwin has been updating it. You should have reviewed the notes for air masses and fronts, and you should have some idea, but this video is a little more of a ability to look over it and hear it and see it in a picture, okay? So let's get started. All right, so cold fronts. Fronts are named by the air entering. So if the air entering is cold air, we're going to say it's cold and dry. So this is CP air, and it's entering from the left, okay? So there's a couple of pieces of information you have to remember about CP air. Obviously, it's cold, dry, so it is more dense, all right, because cold air is compressed and it wants to sink to the ground. So that's really important here. And as that cold, dry air enters, it's going to be replacing warm air. So basically what it's going to be doing is replacing MT air. And let's take a look at some characteristics for MT air. All right, so MT air is warm, moist, so it's got moisture in it, less dense, okay? So essentially, it would be more willing to be moved out of the way by this cold air. So what happens is, as this cold air enters, it forms this kind of a shape right here, okay? And it is heading in this direction, okay? So one thing you should definitely remember is that the cold air entering, here's the symbol for it, all right? The cold air entering wants to move the MT air out of its way. So even though the MT air is generally going in this direction, it's not moving fast enough for the very fast driving cold air. So what it's going to do is start to force it aloft. It's going to drive it up rapidly. So rapidly that what you're going to get is large clouds building, huge clouds building, all right? Big storm clouds, and notice they're going to be right over that frontal boundary, okay? They're right at the frontal boundary. So how this works out and what transpires here is what you're going to have is rising, whoops, let me get the right color for you here. Sorry. Rising MT air will cool right through expansion. This cooling, okay, this cooling causes the air to reach the dew point, or the point at which dew occurs, or in this case, clouds build. And eventually these clouds build into cumulonimbus clouds, right? Big storm clouds. So we have heavy rain, thunder, which is obviously lightning causes thunder. So heavy rain, thunder, and lightning, and all this at the frontal boundary. Oh, let me get that and fix this a little bit. At the frontal boundary, all right? All of this is occurring here. So again, heavy rain's coming down, right? We have a lot of, all right, heavy rain coming down. So here's our rain. Whoops, still working on this computer. Here's our rain. We have lightning and whatever associated thunder. And it is all concealed or kept at this frontal boundary right there, okay? So this is pretty much what you need to know, what you should be able to draw. We always say if you can draw it, you can explain it. So practice drawing it. Check out some videos online about it. I hope this video has helped you a little bit with cold fronts. There'll be a warm front video probably right below it. So hope everyone's safe. Send any questions via email or classroom to Mr. Goodwin and I, and maybe we'll see you soon. All right, stay tight.